Alright, so it is day 9 of quarantine, and we have our next video lesson. Today's lesson is over Isaac Newton's first law of motion. So, Isaac Newton's first law is about inertia. Inertia is the tendency of an object, if it's in motion, to stay in motion, or if it's at rest, it's a tendency to stay at rest unless they're acted upon by another force. So, right now we're going to look at the second half of that because I feel like it's a lot simpler to look at something that's at rest and it's going to stay at rest unless it's acted upon. So, let's mosey on over here. Here's my mayonnaise. It's at rest, it's not moving, and unless I touch it, it's going to stay at rest. It's at rest and it's staying at rest. This is the coffee I made this morning. It's at rest and I don't plan on cleaning it anytime soon, so it's going to stay at rest. Same thing with this dish platter. Cookie sheet. That's what it is. This cookie sheet that I used to cook dinner on. We made some chicky patties. It's at rest right now, and it's going to stay that way because I don't want to clean it. So, these objects are at rest and they're staying at rest because they're not acted upon by another force. That's the second half of inertia. Alright, so we covered the second half of inertia. An object at rest tends to stay at rest unless acted upon. Now we're going to look at the first half, which is an object in motion tends to stay in motion unless it's acted upon by another force. So, look at my candle. It's on the floor. This candle, at this moment, is at rest. I can make it in motion by doing that. And that force itself is something called push. Push is sending an object away from the source. I am the source, I'm sending it away from me, that's a push force. Now we look at it over here. I grab it, bring it towards me. I'm bringing it towards the source, so that's called a pull. These seem rather obvious to me, but there they are. Push and pull forces. Alright, we also have gravity, which I'm sure we all have seen. Water bottle. Gravity is the constant force that's caused by the Earth's mass, not the rotation, by its mass that pulls things down. It's the reason that this water bottle goes down when you drop it. So, gravity, push, pull. Now the one thing that is the real reason that things don't just stay in motion forever when you're pushing on a surface or on Earth in general, the whole reason why it says inertia, an object stays in motion, tends to stay in motion, an object in motion tends to stay in motion unless acted upon by another force, is because of something called friction. Friction is if there's, depending on the texture of the surface of an object and the mass that it has, depends on how much it will slow down. So friction is what slows down an object due to texture and mass. So this candle, I push it. It only goes that far because its mass and texture slows it down as it goes, because this pressure from gravity is pushing it down. Something you can try at home is put your hands together and lightly do this. Lightly run them past each other. It's very easy. There's no real resistance. But then you can apply what we would see as gravity, so you push your hands together and then try to do it, and it's a lot harder to push them past each other because that gravity is causing higher friction, and it's causing it to be harder to move, and it slows it down. Now that texture part I was talking about, let's look at an ice cube. You know, ice cubes are very, very smooth. There's almost no texture, rough texture to them. So we take this, and you know what, let's decrease the friction even more by giving it a buffer between the ground, the surface, and the ice cube itself. And we give it a push, and it goes a lot further. It's because it has much less friction, because it's such a smooth object, and its mass is much lower, so gravity pushing it down isn't going to do as much to keep it from moving in that direction. An object in motion tends to stay in motion unless acted by another force, and the forces acting on the ice cube are very low, so it goes further. That is the first part of inertia, and we already covered the second part. So, push, pull, gravity, and friction are the forces that act on an object. Alright, so just to recap what we just saw, Newton's first law of motion, inertia. So this first law, this inertia, is an object in motion tends to stay in motion, or an object at rest tends to stay at rest unless acted upon by some force. So that's Newton's first law of motion, inertia. So these forces were push, pull, gravity, and friction. So, push and pull, these are our driving forces. These give the motion. Push, an object moves away from the source. So I got my marker, I push it, it moves away from me. That's a push. A pull, an object moves towards the source. So, marker was over here after the push. I bring it towards me. That's a pull. I brought it towards the source, which is me. Gravity is the constant downward pressure caused by Earth's mass. It's not caused by the rotation. It's caused by the mass of the Earth. It's so massive that it brings things in towards it. And then friction, it slows objects and is due to roughness and mass. So remember, just like how we put our hands together, sliding past them gently, it's really easy. We apply gravity, we push together, and now it becomes harder because that friction is much more because we increased the mass. All right, these are your terms. This is Newton's first law of inertia. There's a worksheet. That worksheet is going to be due on Friday. And it's pretty simple. It's just a vocab sheet with a few short answer word problems at the end. So, here you go. This is the last time I'll talk to you before break. I know your break's going to be indoors and home, but it's at least a break from this type of work. And you guys have been doing a lot of work, especially this last week, working with all the teachers. So, good job in all of this. Remember to keep social distancing and stay safe. Yeah, proud of you guys.